Take a deep breath and let your body settle into the soft surface beneath you. Allow your muscles to release their hold as we drift away from the familiar world and toward the quiet, frozen edges of our solar system. We are arriving now at the threshold of Pluto, a world of silent crystalline beauty, located an average of 3.7 billion miles away from the Sun. Out here, at the far reaches of the Kuiper Belt, the Sun is no longer a warm orb, but a brilliant, distant point of light, appearing nearly 1,000 times fainter than it does on Earth. As you step out onto the surface, the first thing you notice is the gravity, or rather, the lack of it. Pluto's gravity is only about 1/15 as strong as Earth's, roughly 0.62 meters per second squared. This means that as you begin your walk, your movements are slow and effortless, each step carrying you in a gentle, buoyant arc, as if you are moving through a dream. The ground beneath your boots is not rock, but a vast, shimmering expanse of exotic ices. You are standing on Sputnik Planitia, a massive glacial basin that forms the left lobe of Pluto's famous heart-shaped feature, Tombaugh Regio. This basin is 1,000 kilometers wide, an icy sea so large it could cover the states of Texas and Oklahoma combined. Here, the temperature is a staggering 40 Kelvin, which is approximately -387 degrees Fahrenheit. At these temperatures, the chemistry of the world changes. The bedrock of Pluto is actually made of water ice, which at 40 Kelvin is as hard and brittle as granite. But the surface you are walking on is composed primarily of frozen nitrogen, mixed with traces of methane and carbon monoxide. What is fascinating about nitrogen ice is its viscosity. On Earth, we think of ice as a solid, unyielding substance, but here, nitrogen ice is soft and plastic. It flows with the consistency of toothpaste or a slowly moving glacier, even at these frigid temperatures. As you press your hand against the surface, you wouldn't feel a jagged frozen crust, but a smooth, slightly yielding texture, like a fine-grained wax. If you were to listen closely, you might hear the faint, crystalline creak of the ice shifting, a slow, deep groan that resonates through the soles of your feet as the glacier adjusts under its own immense weight. Look down at the patterns beneath you. Most people don't know that Sputnik Planitia is not a flat, featureless plain. It is divided into a mesmerizing honeycomb pattern of giant polygons. These cells are roughly 20 to 30 miles across. They are the result of thermal convection. Deep beneath the surface, the interior of Pluto still retains a small amount of heat from its formation and the decay of radioactive elements. This heat causes the solid nitrogen to warm up just enough to become buoyant. It rises to the center of these polygons in a slow-motion simmer, cools as it reaches the surface, and then sinks back down along the dark, etched borders of the cells. You are walking across the top of a planetary-scale lava lamp, where the lava is frozen gas, and a single cycle of rising and falling takes hundreds of thousands of years. The air around you is impossibly thin, with an atmospheric pressure about 100,000 times less than that of Earth, roughly 10 microbars. Yet, it is visible. Looking toward the horizon, you see a delicate, ethereal blue haze. This isn't just a trick of the light. It's caused by Rayleigh scattering, the same phenomenon that makes Earth's sky blue. On Pluto, sunlight breaks down methane and nitrogen molecules in the upper atmosphere, creating complex organic particles called tholins. As these tholins drift downward, they form over 20 distinct layers of haze that stretch more than 1,000 miles above the surface. It gives the landscape a soft, filtered glow, as if you are looking at the world through a veil of fine blue silk. As you continue your walk toward the edge of the basin, the terrain begins to change. To your left, you see a range of mountains rising sharply from the White Plains. These are the Hillary Montes, named after Sir Edmund Hillary, and they reach heights of about 11,000 feet, comparable to the Rocky Mountains on Earth. What is truly incredible is that these mountains are made of water ice. Because nitrogen ice is denser than water ice, these massive mountain ranges are essentially floating. They are like colossal icebergs trapped in a sea of frozen nitrogen. You can see where the nitrogen glaciers have flowed around the base of these mountains, carving smooth, wide channels through the landscape over eons. The light here is unlike anything on Earth. During the day, the illumination is roughly equivalent to the light on Earth just after sunset, a period scientists call Pluto time. It is a permanent silvery twilight. You can see the stars even when the sun is up, their cold light reflecting off the methane frost that coats the mountain peaks. In this methane frost is another wonder of this world. Methane on Pluto acts much like water does on Earth. It sublimates from a solid to a gas in the warmer areas, and then condenses as a sparkling white frost on the higher, colder elevations. As you brush your hand against a nearby rock of water ice, the methane crystals feel like powdered sugar, dry and incredibly fine, catching the dim sunlight and scattering it like a handful of diamonds. Something most people find surprising is that Pluto has dunes. As you walk near the borders of Sputnik Planitia, you encounter vast fields of rhythmic ripples in the ice. These aren't made of sand, but of tiny grains of methane ice, about 200 to 300 micrometers in diameter. Despite the thin atmosphere, the sublimation of nitrogen ice creates just enough of a breeze, perhaps 20 miles per hour, to lift these methane grains and deposit them into long, sweeping dunes. The sound of the wind here would be a mere whisper, a ghostly breath of moving gas that barely has the density to be felt, yet it shapes the very face of the planet. Listen to the silence. It is a profound, absolute quiet that exists only in the vacuum-adjacent spaces of the outer solar system. There is no rustle of leaves, no hum of insects, no distant roar of traffic. There is only the rhythmic sound of your own breathing and the soft, slow crunch of nitrogen crystals beneath your feet. The nitrogen ice is incredibly pure here, making the surface of Sputnik Planitia one of the brightest spots in the solar system. It reflects up to 60% of the sunlight that hits it. As you look closer at the ground, you notice that the ice isn't just white. There are subtle swirls of pale pink and deep cream. These colors come from the carbon monoxide ice that is sequestered within the nitrogen. Carbon monoxide is most concentrated in the center of the heart, and its presence slightly alters the way the ice reflects light, giving the landscape a soft pastel palette that feels peaceful and serene. Further in the distance, you can see the dark, reddish-brown expanse known as Cthulhu Macula. This area is ancient, billions of years old, and heavily cratered, providing a stark contrast to the smooth, young surface of the glaciers you are walking on. The red color comes from a thick coating of tholins, those organic molecules that have rained down from the atmosphere for eons, accumulating like a layer of dark, cosmic soot. This transition from the bright, youthful ice of the basin to the dark, ancient highlands is a reminder of the incredible timescales at work here. On Pluto, young surface ice like Sputnik Planitia is still nearly 100 million years old, yet it is considered new compared to the 4-billion-year-old terrain surrounding it. The scale of the landscape is difficult to grasp. Because of Pluto's small size, it's only about 1,400 miles wide. The horizon is much closer than it is on Earth. This creates a sense of intimacy with the terrain. You feel as though you are standing on a small, precious island in the dark ocean of space. Yet, the mountains that ring the basin are gargantuan. To the north, the Alidrisi Montes feature jagged, chaotic peaks where the water ice crust has been smashed and tilted by some ancient, slow-motion upheaval. As you walk, you might notice small pits in the ice, known as sublimation pits. These form when the sun's rays, dim as they are, hit a specific spot and turn the solid nitrogen directly into gas without it melting first. These pits can grow to be hundreds of feet wide, creating a landscape that looks like the surface of a golf ball or a piece of weathered bone. The edges of these pits are smooth and rounded, shaped by the gentle transition of molecules from the ground into the thin blue sky. Your journey across the glacier is a study in slowness. In the low gravity, your heart rate slows, your muscles relax. Every movement is deliberate and graceful. The sheer cold of the world is not a biting, painful cold, but a preservative, a stillness that keeps the landscape exactly as it has been for millions of years. It is a world in stasis, a quiet library of the solar system's history. Here, the passage of time is measured in the slow drift of nitrogen ice and the gradual accumulation of methane frost. As you look up, you see Charon, Pluto's largest moon. It hangs motionless in the sky, appearing 7 times larger than Earth's moon does to us. Because Pluto and Charon are tidally locked, they always show the same face to one another. Charon doesn't rise or set, it simply hovers, a giant gray sentinel draped in its own canyons and icy plains. The sight of it provides a sense of companionship in the vast dark. You are not alone on this walk. You are part of a celestial dance that has been performed in perfect silent harmony for billions of years. Take one more slow, buoyant step. Feel the softness of the nitrogen ice beneath you. In smelling the air, if you could, would reveal the faint chemical scent of frozen hydrocarbons, a clean, sharp aroma like the cold metallic tang of a winter morning. Everything here is pure. Everything is still. The glaciers of Pluto are a place of infinite rest, a vast white sanctuary where the rhythms of the universe slow down to a heartbeat. You are drifting now, further into the heart of the ice, moving deeper into the quiet, crystalline peace of this distant frozen world. Continuing your journey across the ivory plains of Sputnik Planitia, it helps to ground your perspective in how humanity first came to perceive this distant, frigid world. For nearly all of human history, Pluto remained a phantom, an invisible wanderer in the dark. It wasn't until February 18, 1930, that a 24-year-old astronomer named Clyde Tombaugh finally caught a glimpse of it. Imagine him at the Lowell Observatory in Arizona, hunched over a machine called a blink comparator. This device allowed him to flip rapidly between 2 photographic plates of the same patch of sky, taken nights apart. While the distant stars remained fixed, a tiny 14th magnitude speck of light seemed to jump back and forth. This was the moment our understanding of the solar system expanded. That speck of light was the very ground you are walking on now, a world so far away that sunlight takes 5.5 hours to reach its surface. The naming of this world is an equally quiet, thoughtful tale. An 11-year-old girl in Oxford, England, named Venetia Burney, suggested the name Pluto during a breakfast conversation with her grandfather. She felt the name of the Roman god of the underworld was fitting for a planet that resided in the lonely, dark reaches of space. The Lowell Observatory staff agreed, noting that the first 2 letters of Pluto, P and L, honored Percival Lowell, the astronomer who had spent years searching for Planet X. Consider the weight of that history as you look toward the horizon. For 85 years after its discovery, Pluto remained little more than a blurry pixel in our strongest telescopes. It wasn't until July 2015, when the New Horizons spacecraft performed its historic flyby, that we finally saw the texture of the ice beneath your feet. What's truly striking about the geography here is its relative youth. While much of the solar system is scarred by craters from billions of years of impacts, the nitrogen glaciers of Sputnik Planitia are remarkably smooth. Scientists have determined that this ice is no more than 100 million years old, a mere blink in geological time. This suggests that Pluto is geologically alive. The lack of craters means the surface is constantly being refreshed, a process known as resurfacing. As you glide over the polygons, you are witnessing a planet that is still breathing, still renewing its skin through the slow thermal churning of nitrogen. Consider the sheer distance the New Horizons probe had to travel to bring us these images: 3 billion miles. The spacecraft was moving at a staggering 36,000 miles per hour, making it one of the fastest human-made objects ever launched. Yet, even at that speed, the journey took 9.5 years. When it finally arrived, it had only a few hours to gather the bulk of its data before hurtling back out into the Kuiper Belt. The radio signals carrying the first high-resolution images of these glaciers traveled at the speed of light, yet they still took 4.5 hours to reach the giant antenna dishes on Earth. You are standing on the frontier of our most recent and profound astronomical discovery. One of the most significant revelations of that mission was the presence of cryovolcanism. To your south lies a massive mountain called Right Mons. It stands about 2.5 miles high and spans nearly 93 miles across. What makes Right Mons exceptional is that it isn't a mountain of rock, nor a volcano of molten lava. It is a cryovolcano. Instead of fire, it likely spewed a viscous slurry of water ice, ammonia, and perhaps methane. Picture the texture of a half-melted slushy rising from the interior and flowing across the surface. Because Pluto's crust is mostly water ice, which becomes buoyant when mixed with ammonia, these volcanoes are essentially plumbing systems for the planet's hidden interior. The hummocky, undulating texture of the ground near Right Mons is the result of multiple volcanic domes merging together over eons, creating a landscape that looks like a frozen, bubbling cauldron. Deep beneath the water ice crust, something even more surprising may exist. Calculations of Pluto's density and its gravitational relationship with its moon, Charon, lead many scientists to believe there is a liquid ocean hidden about 100 miles below the surface. This ocean would be kept liquid not by the sun, but by the heat generated from the decay of radioactive elements like uranium and thorium in Pluto's rocky core. This liquid layer acts as a lubricant, allowing the outer shell of the planet to shift and realign itself. At this very moment, you are walking atop a 60-mile thick layer of nitrogen and water ice, which itself may be floating on a dark, salty sea. This thermal insulation is so effective that even 4.5 billion years after the planet's formation, the interior remains warm enough to prevent the world from freezing solid to its core. The way Pluto moves through space also dictates the quiet rhythms of the landscape. Pluto has a 248-year orbital period, meaning it has not even completed a single full orbit since its discovery in 1930. Its path is highly elliptical and swinging from as close as 2.7 billion miles to as far as 4.6 billion miles from the Sun. Between 1979 and 1999, Pluto was actually closer to the Sun than Neptune. During these warm periods, the nitrogen and methane ice on the surface sublimates into a thin atmosphere. But as the planet moves further away, into its long, century-long winter, the atmosphere is predicted to undergo a dramatic collapse. The gas will cool and freeze, raining down as a fresh layer of frost across the glaciers. You are currently experiencing the planet in its active phase, where the air is still thick enough, relatively speaking, to support the blue hazes and the formation of methane dunes. Notice the orientation of the sky. Unlike Earth, which is tilted at about 23.5 degrees, Pluto is tilted at an extreme 120 degrees on its side, and this causes extreme seasonal variations. On Earth, we have 4 seasons in a year. On Pluto, a single season can last for decades. At the poles, you might experience over 100 years of continuous sunlight, followed by a century of total darkness. This radical tilt is likely the result of a massive collision billions of years ago with another Kuiper Belt object, a cosmic encounter that also likely formed Pluto's 5 moons: Charon, Styx, Nix, Kerberos, and Hydra. The relationship between Pluto and its largest moon, Charon, is unique in our solar system. Charon is half the size of Pluto, making the two a binary system. They don't just orbit each other, they orbit a common point in space between them, called a barycenter. This gravitational tug-of-war is what keeps the interior of Pluto warm through tidal heating. Imagine the subtle stretching and squeezing of the planet's crust as Charon exerts its pull, a slow-motion massage that generates the heat necessary to keep those nitrogen glaciers flowing. As you observe the different shades of the ice, you might notice streaks of darker material. Scientists have identified these as wind streaks, which provide evidence of Pluto's subtle weather patterns. Even though the atmosphere is incredibly thin, the temperature differences between the bright plains of Sputnik Planitia and the dark tholin-covered highlands create local pressure gradients. This produces gentle winds that can transport small particles of hydrocarbon soot across the ice. It's a delicate, silent dusting of the landscape, a natural painting process that takes centuries to complete. Another fascinating detail involves the chemical composition of the air you're moving through. In 1988, astronomers watched as Pluto passed in front of a distant star, an event known as an occultation. They expected the star's light to blink out instantly, but instead, it faded gradually. This was the first definitive proof that Pluto possessed an atmosphere. This atmosphere is dominated by nitrogen, much like Earth's, but it also contains about 0.5% methane and traces of carbon monoxide. At the high altitudes where the sunlight hits these molecules, complex chemical reactions occur, building larger and larger organic molecules that eventually settle on the ground like a fine reddish mist. As you stand in the center of the nitrogen glacier, you are standing on a giant reservoir of frozen volatiles. Sputnik Planitia acts as a cold trap, a massive basin where the planet's nitrogen naturally accumulates. Because the basin is deeper than the surrounding terrain, about 2 miles deep, it is slightly warmer and higher in pressure at the bottom, which helps drive the convection cells you observed earlier. The nitrogen here isn't just sitting still, it's a giant slow-motion engine that regulates the planet's climate and surface pressure. Picture the sheer stillness of this environment. On Earth, we are used to the constant movement of water, the rush of a stream, the crashing of waves. Here, the flow is so slow that a single ripple in the nitrogen glacier might take 1,000 years to move just a few inches. It is a world that operates on a timeline far beyond the human lifespan. The historical discovery of this world, From a jumping dot on a photographic plate to a complex world of cryovolcanoes and hidden oceans, reminds us of the patience required to understand the universe. You are a guest in this ancient, silent gallery. Every crystal of methane frost, every polygon of nitrogen ice, and every mountain of floating water ice is a testament to the quiet persistence of natural forces. The sunlight, though dim, still manages to paint the sky blue and the ground red. The gravity, though weak, still manages to hold a complex system of moons in orbit. As you prepare to move further across the ice, feel the profound connection between the history of our discovery and the timeless reality of this world. You are walking through a living archive of the solar system, a place where the past and the present are frozen together in a beautiful, shimmering stasis. As you continue your effortless trek across the frozen heart of Pluto, take a moment to look down at the ground and consider the strange chemistry beneath your boots. What's happening now is a complete reversal of our earthly experience. On Earth, we build our world on a foundation of silicate rocks and metals, but here, the very bedrock is made of water ice. Because it is so intensely cold, around 40 degrees above absolute zero, this water ice doesn't behave like the slippery cubes in a drink or the slush on a winter sidewalk. Instead, it is as rigid and unyielding as granite or basalt. Imagine walking through a mountain range where the jagged peaks and deep valleys are made entirely of frozen H2O, so cold that it has become the structural stone of the planet. Now, compare that to the nitrogen ice of the Sputnik Planitia glaciers you are currently traversing. While the water ice mountains are the rock, the nitrogen ice is the soil and the sea. Scientists have found that at these temperatures, nitrogen ice has a hardness similar to a stick of room temperature butter or a bar of soft soap. As you walk, your boots don't clatter against a hard surface. They sink ever so slightly, creating a muted, muffled sensation. Each step feels cushioned, as if you are walking across a vast, endless floor of dense upholstery. This softness allows the nitrogen to flow, behaving like a slow-motion liquid that carves its way through the harder, water-ice landscape. Look toward the horizon at the Tartarus Dorsa region, where the terrain takes on a bizarre, repetitive texture that scientists call snakeskin. Imagine a field of giant, jagged shards of glass, each one the size of a skyscraper. These are known as penitentes. On Earth, we see these in the high Andes Mountains, but they are rarely more than a few inches or feet tall. On Pluto, because the atmosphere is so thin and the gravity so weak, these blades of methane ice can grow to staggering heights of 500 meters, nearly 1,600 feet. They are formed through a process called sublimation, where the sun turns the solid ice directly into gas, carving out deep troughs and leaving behind these towering serrated ridges. From your vantage point, they look like a forest of pale, silent thorns, standing perfectly still in the dim, silvery light. Notice how your body feels in this environment. Pluto's gravity is roughly 6% of Earth's. To put that into a familiar perspective, if you weigh 150 pounds at home, you would weigh only about 10 pounds here. Moving across the glaciers feels less like walking and more like a series of controlled, graceful glides. You can jump over a small crevasse and remain in the air for several seconds, descending with the lightness of a feather. This low gravity is what allows the mountains of water ice to float on top of the denser nitrogen glaciers. Think of a bowl of soup where the croutons represent the mountains and the broth represents the nitrogen ice. Because water ice is about 8% less dense than nitrogen ice, these massive mountain ranges, some 11,000 feet high, are literally drifting, bobbing with imperceptible slowness in a sea of frozen gas. The atmosphere around you, though nearly a vacuum, has its own delicate weight. At the surface, the atmospheric pressure is about 10 pascals. For comparison, the pressure on Earth at sea level is over 101,000 pascals. Walking through Pluto's air is like standing on Earth at an altitude of 50 miles, the very edge of space. You wouldn't feel a breeze against your skin as a forceful push. Instead, it would be a ghostly, almost intangible suggestion of movement. This air is composed of 99% nitrogen, but that remaining 1% of methane is what creates the planet's signature colors. Consider the snow that occasionally dusts the peaks of the Cthulhu Macula Highlands. It isn't made of water, but of methane frost. Just as Earth has white snowcaps on its mountains, Pluto has white caps of methane. However, as this methane is processed by the faint ultraviolet light from the distant sun, it undergoes a chemical transformation. It turns into tholins, complex organic molecules that resemble a fine, reddish-brown soot. Picture a landscape dusted with a layer of dark cocoa powder or crushed cinnamon. This dust is slightly oily to the touch and covers the ancient cratered regions of the planet in a velvet-like coating of rich umber tones. Deep within the nitrogen glaciers, the process of convection continues its silent work. Scientists have measured the speed of this movement and found that the ice in the center of the polygons rises at a rate of only a few centimeters per year. This is about the same speed that your fingernails grow. While it seems stationary to our eyes, on a planetary timescale, the surface is a boiling pot of water. Every 100 million years, the entire surface of the 1,000-kilometer-wide basin is completely refreshed. This is why you see so few impact craters here. The planet is constantly erasing its history, smoothing over the scars of space with a fresh layer of soft, pale ice. The heat driving this movement is incredibly subtle. Deep in the core of Pluto, the decay of radioactive elements like potassium, thorium, and uranium produces a tiny amount of warmth, estimated at about 3 to 5 milliwatts per square meter. To visualize this, imagine a single tiny Christmas tree bulb buried miles beneath the ground, providing just enough energy to keep the massive glaciers of the surface in their slow churning dance. This internal warmth is also what likely maintains the liquid water ocean beneath the crust, preventing the entire world from freezing into a solid, inert block of ice. Notice the light again. It is currently Pluto time, that period of twilight where the sun is just a bright star. On Earth, we measure the brightness of the sun in lux. A sunny day on Earth is about 100,000 lux. On Pluto, it is about 100 lux. This is roughly the same amount of light you would find in a dimly lit hallway or a cozy living room in the evening. It is enough to see clearly, to distinguish the pinks of the carbon monoxide ice from the whites of the nitrogen. But it never glares. It is a soft, permanent dusk that allows your eyes to relax, focusing on the subtle textures of the frost without strain. Look closely at the surface of a nearby water ice boulder. You might see small sparkling grains embedded in the surface. These are methane ice crystals, typically between 200 and 300 micrometers in size, about the thickness of 3 sheets of paper. They catch the dim light like tiny sequins. What's happening here is a delicate exchange of matter. During Pluto's long year, the nitrogen ice sublimates into the air and then settles back down elsewhere as frost. It is a world of constant silent migration, where the very ground you stand on is slowly evaporating and rebuilding itself in a different location. The sounds of this world are a study in minimalism. Without a thick atmosphere to carry vibrations, noises are short-lived and intimate. If you were to drop a fragment of water ice, it wouldn't ring out with a sharp crack. Instead, the thin air would swallow the sound almost instantly, leaving only a soft, dull thud that you would feel more in your feet than hear in your ears. See, the dominant sound is the internal rhythm of your own suit, the steady mechanical hum of the life support, and the rhythmic whoosh of your breath, which provides a comforting metronomic counterpoint to the absolute silence of the Kuiper Belt. The scale of the cells, or polygons you are walking across, is vast. Each cell is roughly 20 to 30 miles across. If you were to stand in the center of one, the edges would be beyond the horizon because of Pluto's curvature. You are walking across the top of a giant frozen bubble of nitrogen. Below you, that bubble extends down for about 6 miles before it hits the water ice basement. The edges of these bubbles are marked by dark troughs where the cooled nitrogen sinks back down. In these troughs, you can sometimes find ice hills, fragments of water ice that have been swept into the valleys like leaves in a gutter. Scientists discovered through the New Horizons mission that these troughs are often filled with dark material, likely those same reddish tholins we saw earlier. The contrast is striking. Bright, creamy white plains, separated by dark, etched lines of deep mahogany. It looks like a giant, natural mosaic, a piece of planetary-scale stained glass laid out across the floor of the basin. As you move, observe the blue haze layers in the sky once more. Each layer is about 20 kilometers thick, and they are separated by clear gaps. Think of them like a stack of nearly transparent blue silk sheets draped over the planet. These hazes are not clouds in the traditional sense. They don't produce rain or snow. Yeah, they are a chemical fog, a byproduct of the sun's distant touch, slowly settling toward the surface to become the red dust of the highlands. This cycle, the rising of gas, the formation of haze, the descent of organic dust, and the churning of the glaciers, is the heartbeat of Pluto. It is a slow, steady, and incredibly peaceful system. Everything here is interconnected in a way that feels deeply settled. The gravity, the ice, the light, and the thin air all work together to create a world of profound stillness and constant microscopic change. As you continue your walk, let the simplicity of this world's cycles ground you. There is no rush here. There are no deadlines. There is only the slow rise of nitrogen, the faint glimmer of methane frost, and the long, quiet shadows cast by mountains made of water. You are moving through a masterpiece of celestial mechanics, a place where time is measured in millions of years, and every movement is a testament to the quiet, enduring beauty of the natural world. Picture this. As you continue your quiet journey across the glaciers, you are walking over the basic ingredients of life itself. What's happening now is a profound chemical conversation between the surface and the sky. Scientists discovered that those reddish-brown stains you see in the distance, the tholins, are more than just cosmic soot. They are complex organic molecules. On Earth, these types of carbon-rich compounds were the precursors to the very first biological cells. Consider the fact that out here, billions of miles from any known forest or ocean, the universe is essentially slow cooking the building blocks of existence. It is a planetary-scale kitchen where the recipes take millions of years to develop, using ultraviolet light from the sun to break down methane molecules and recombine them into heavy, sticky chains of atoms that rain down like a gentle, dark powder. Notice how the ground feels as you transition toward the eastern edge of the nitrogen plain. You are approaching Virgil Fosse, a system of massive troughs and cracks that stretches for over 1,600 kilometers across the surface. Within these deep fissures, something very specific was found: signatures of ammonia-rich ice. This is a vital clue to the world's hidden activity. Ammonia acts as a natural antifreeze. On Earth, we use it in industrial cooling, but here, it likely keeps Pluto's internal water liquid at much lower temperatures than normal. Picture a subterranean sea, perhaps 100 to 180 kilometers deep, where ammonia prevents the water from turning into solid ice. This means that far beneath your feet, there is a dark, salty ocean that has remained liquid for over 4 billion years. This hidden reservoir may contain more water than all of Earth's oceans combined, tucked away in the silent, pressurized darkness of the interior. At this very moment, your own body provides a small point of heat in this frozen landscape, much like the radioactive elements deep in Pluto's rocky core. Deep within the planet, isotopes like potassium-40, thorium-232, and uranium-238 are slowly decaying. Scientists have calculated that the decay of potassium-40 alone generates about 20.9 watts of heat for every kilogram of the isotope. It is a tiny, steady glow of energy, comparable to a soft heating pad left on the lowest setting. This internal warmth is what drives the nitrogen cycle you see on the surface. Every year on Pluto, which, remember, lasts 248 Earth years, approximately 10 billion tons of nitrogen gas sublimates from the sunlit hemisphere and travels through the thin atmosphere to freeze onto the winter pole. It is a gargantuan, silent migration of matter, a seasonal breath that moves billions of tons of gas across the world with the quiet grace of a falling snowflake. Notice the play of light on the horizon as you look toward Pluto's largest moon, Charon. Charon is 1,212 kilometers in diameter, more than half the size of Pluto itself. Because of this, the two objects are actually a binary system. They orbit a point in space, between them called a barycenter, which sits about 960 kilometers above Pluto's surface. Picture a pair of dancers spinning slowly in the dark, held together by an invisible thread of gravity. What's truly fascinating is that Pluto and Charon are double tidally locked. This means they always show the same face to one another. If you were to stay in this spot on the glacier, Charon would never move across the sky. It would remain fixed in the exact same position, a constant, comforting presence hovering over the frozen horizon. Consider the other members of this celestial family. In addition to Charon, you are being watched by 4 much smaller moons: Styx, Nix, Kerberos, and Hydra. These moons are not spheres, but are shaped like irregular river stones or potatoes. Nix and Hydra are the largest of the 4, roughly 40 to 50 kilometers in length. Scientists discovered that these small moons don't behave in an orderly fashion. While Charon is locked in a stable embrace with Pluto, the smaller moons tumble and wobble chaotically as they orbit. Because Pluto and Charon create a shifting gravitational field, the smaller moons are constantly being tugged and twisted, spinning in unpredictable patterns as they zip through the void. It is a reminder that even in the most peaceful environments, there is a hidden, rhythmic complexity at play. As you walk, look closely at the peaks of Picard Mons to your south. This is another massive cryovolcano, even larger than the ones we discussed earlier, standing about 5.6 kilometers high, nearly twice the height of Mount Whitney in California. The lava that once flowed from this peak was a mixture of water ice and methane, which has a much lower density than the nitrogen ice of the plains. Methane ice has a density of only about 0.42 grams per cubic centimeter, while the nitrogen ice you are standing on is much denser, at 1.027 grams per cubic centimeter. This density difference is why the methane-rich mountains seem to sit so high and proud above the nitrogen plains. They are essentially floating, buoyed by the heavier material beneath them, like a cork bobbing in a basin of water. Think about the sheer age of the atoms that make up the frost on your boots. The methane molecules on Pluto have a long and storied history. Scientists have estimated that it takes about 10,000 years for ultraviolet light from the sun to break down a single methane molecule in Pluto's atmosphere. This means that the haze you see is the result of thousands of years of patient solar labor. These molecules are the remnants of the original nebula that formed our entire solar system 4.5 billion years ago. Pluto is a planetary archive, a deep freeze storage unit that has preserved the chemistry of the early sun in a state of pristine, crystalline perfection. You are walking through the very beginning of our cosmic story. At this very moment, take a breath and think about the atmosphere you are moving through. It is incredibly thin, yet it is enough to interact with the solar wind, the stream of charged particles flowing from the sun. Because Pluto lacks a magnetic field, the solar wind strikes the upper atmosphere directly. This creates a soft barrier, where Pluto's escaping nitrogen gas is ionized and swept away into a long tail that stretches for thousands of miles behind the planet. However, some of this gas doesn't escape into space. It is caught by Charon. Scientists found a dark red region at Charon's northern pole, nicknamed Mordor Macula. This red stain is actually made of Pluto's own atmosphere. The nitrogen and methane from Pluto drift across the gap, settle on Charon's cold pole, and are processed into red tholins by cosmic rays. It is a shared heritage, a physical bridge of gas and color, connecting the two worlds. Notice how the polygons of Sputnik Planitia are not perfectly static. If you were to place a marker in the ice and return in a year, you would find it had moved. The nitrogen ice flows at a rate of approximately 5 to 10 centimeters per year. This is remarkably similar to the speed at which tectonic plates move on Earth. While our continents shift because of the heat in Earth's mantle, Pluto's glaciers shift because of the subtle warmth of its radioactive core and the soft plastic nature of nitrogen ice. It is a world that mimics the geological behavior of a much larger planet, but it does so in a way that is quiet, slow, and infinitely patient. Consider the size of the sun from this distance. It appears only 0.8 arc minutes in diameter. To your eyes, it would look like a brilliantly bright cold star, not much larger than Jupiter appears from Earth, but significantly more luminous. Despite its small size, its influence is everywhere. It drives the 20 distinct layers of haze that extend 1,600 kilometers into the sky. It provides the energy for the snakeskin textures of the Tartarus Dorsa region. It is a distant but constant conductor, orchestrating the slow movements of the ice and the gentle transitions of the seasons. The silence here is a profound, velvety layer that wraps around you. Because the atmospheric pressure is only about 10 microbars, 100,000th of Earth's, there is no medium for sound to travel long distances. If a mountain made of water ice were to shift, or a cryovolcano were to release a slow, viscous flow of ammonia, slush, it would happen in near total silence. You are experiencing a world of pure visual and tactile sensation. The texture of the methane frost, the soft resistance of the nitrogen ice, and the weightless feeling of the low gravity all combine to create a sense of deep, internal peace. permit your mind to reflect on the connection between this distant world and our own life. We are all made of the same stardust, the same carbon, nitrogen, and oxygen that paints the surface of Pluto in shades of pink and red. The same laws of physics that allow a 5-kilometer-high mountain of ice to float on a nitrogen glacier also govern the movement of the clouds in our sky and the flow of blood in our veins. Out here, on the edge of the solar system, the complexity of life is stripped down to its most basic, beautiful components. It is a place of profound simplicity, where the only thing that matters is the slow, steady rhythm of the planet's breath. As you prepare to move deeper into the twilight of the glaciers, feel the stability of the ground beneath you. Even though it is moving with a purpose and a timescale that dwarfs human worry. The ice has been here for millions of years, and it will be here for millions more, slowly churning, refreshing itself, and holding its secrets in the cold. You are part of this enduring cycle, a temporary observer of a timeless masterpiece. Each step you take is a connection to the vast history of the universe, a history that is written in the crystals of methane and the slow, buoyant drift of nitrogen ice. Keep moving forward, gently and quietly, into the heart of the frozen world. Notice how the texture of the ground changes as you move closer to the center of a convection cell. Scientists discovered that nitrogen ice undergoes a specific phase transition at 35.6 Kelvin. Above this temperature, the ice exists in a beta phase, where the nitrogen molecules are oriented in a hexagonal, close-packed structure that allows them to slide past one another with ease. This is why the glaciers beneath you feel so surprisingly pliable, almost like a massive sheet of chilled silicone. Because Pluto's surface hovers around 40 Kelvin, the ice stays in this soft plastic state, allowing it to flow and heal any cracks or impact scars that try to form. At this very moment, you are walking on a substance that is technically a solid, yet behaves like a slow-moving river, a planet-sized quilt of frozen gases that is constantly rearranging its own fibers. Consider the thermal conductivity of the materials around you. Water ice, which forms the rugged mountains on the horizon, is a relatively good conductor of heat compared to nitrogen ice. Scientists have found that nitrogen ice is about 10 times more insulating than water ice. This means that the heat rising from Pluto's core is trapped beneath these thick glaciers, creating a thermal blanket that helps maintain the liquid ocean deep below. Picture this. The nitrogen glaciers act like the insulation in the walls of a house, keeping the interior warmth from escaping into the freezing vacuum of space. This insulation is so effective that even though the surface is nearly 400 degrees below 0 Fahrenheit, the water deep below could remain liquid for billions of years. What's happening now is a curious acoustic phenomenon. Because the atmospheric pressure is a mere 10 microbars, the way sound behaves is radically different from what we experience on Earth. In such a thin medium, high-frequency sounds are absorbed almost instantly by the nitrogen molecules. If you were to tap two pieces of water ice together, the clink would be muted, losing its sharp edge and becoming a dull, low-frequency thud. The speed of sound here is also slower, moving at roughly 200 meters per second compared to 343 meters per second on Earth. This creates a sonic environment that feels heavy and dampened, as if you are moving through a world wrapped in layers of thick, sound-absorbing felt. The only vibration that truly carries is the one you feel through the soles of your feet, the deep infrasonic pulse of the glacier as it adjusts under the weight of its own mass. Scientists discovered that the bright reflective nature of Sputnik Planitia is due to its high albedo, which ranges from 0.6 to 0.9. This means the glacier reflects up to 90% of the sunlight that reaches it. By contrast, the dark Cthulhu macula highlands reflect only about 10%. This difference in reflectivity drives a thermal engine on the surface. The dark areas absorb more solar energy and become slightly warmer, perhaps by only 10 or 20 degrees, causing any nitrogen frost there to sublimate into gas. This gas then travels to the colder, brighter glaciers, where it deposits as fresh, white frost. At this very moment, you are standing in the solar system's most efficient cold trap, a basin that actively pulls nitrogen from the rest of the planet and locks it away in a shimmering, frozen reservoir. Notice the subtle scent of the atmosphere, or rather, the chemistry that creates it. While you are protected within your suit, the chemical composition of the tholins that dust the red highlands is scientifically intriguing. These complex organic solids are created when ultraviolet light and cosmic rays strike methane and nitrogen. Lab experiments on Earth that simulate Pluto's environment have found that these tholins often contain nitriles and hydrocarbons. If you were able to smell them, they might possess a faint, sharp aroma, reminiscent of bitter almonds or the scorched scent of a cold fireplace. It is a clean, antiseptic smell of high-energy chemistry happening in a low-energy world, the scent of the universe's raw materials being forged in the dark. Deep within the nitrogen ice, the pressure builds as you go further down. Scientists have calculated that at the bottom of the 10-kilometer deep basin, the pressure is high enough to reach the triple point of nitrogen. This is the specific temperature and pressure where nitrogen can exist as a solid, a liquid, and a gas, all at the same time. While it's unlikely there are large lakes of liquid nitrogen, there may be a thin film of liquid at the very base of the glacier, acting as a lubricant. This allows the massive sheets of ice to slide over the water ice bedrock with minimal friction. Imagine the entire 1,000-kilometer glacier as a giant, icy tectonic plate, gliding silently across the world on a microscopic layer of liquid nitrogen. Consider the microscopic structure of the methane frost that occasionally glitters on the surface. These crystals are not the six-sided flakes we see on Earth. Instead, methane ice crystals at these temperatures tend to form cubic or octahedral shapes, and they are incredibly small, often only 100 micrometers across, roughly the diameter of a human hair. When the sun hits them, they don't melt. They undergo a process called sintering, where the points of the crystals fuse together without turning into liquid. This creates a crunchy, crusty texture on the surface of the softer nitrogen ice. As you walk, you can feel this thin, brittle layer snapping beneath you, a delicate rhythmic vibration that signals the transition between different types of frozen gas. Notice how the colors of the landscape are distributed. The pale cream and pink hues of the glaciers are not uniform. Scientists discovered that carbon monoxide ice is most concentrated in the center of Sputnik Planitia. Carbon monoxide is more volatile than nitrogen, meaning it turns into gas more easily. However, it seems to be trapped within the nitrogen crystal lattice, creating a subtle color gradient. Toward the edges of the basin, the ice becomes whiter and purer, while the center holds onto a soft, rosy glow. This is a visual map of the planet's temperature. The slightly warmer center of the convection cell holds a different chemical signature than the cooler edges, where the ice sinks back into the depths. What's happening now is the slow process of viscous relaxation. Because water ice is so much harder than nitrogen ice at 40 Kelvin, Any craters that do form in the water ice crust stay there for billions of years. But in the nitrogen glaciers, any depression is filled in almost immediately by the flowing ice. Scientists have found that a crater a mile wide would vanish in the nitrogen plains in less than a few thousand years. You are walking on a surface that refuses to remember its trauma, a world that continually smooths its own forehead, erasing the impact of every stray asteroid and comet that dares to disturb its peace. Picture this. The blue haze of the atmosphere is actually a form of photochemical smog. The particles that make up the haze are incredibly small, only about 0.1 to 0.5 micrometers in size. This is the perfect size to scatter blue light while letting red light pass through, which is why the sky looks blue, but the sun looks like a sharp white point. These particles are not water droplets or ice crystals, but soot made of heavy organic molecules. As they slowly drift downward, falling at a rate of only a few centimeters per second, they aggregate into larger clusters. By the time they hit the ground, they have grown into the dark, complex tholins that paint the mountains red. It is a slow-motion rain of organic matter, a gentle, invisible fall that has been occurring for 4 billion years. Scientists discovered that Pluto's density is about 1.85 grams per cubic centimeter. This tells us that the planet is roughly 65% rock and 35% ice by mass. This high rock content is crucial. It means there is a significant amount of heat-generating material in the core. Without this rocky heart, the nitrogen glaciers would be static and dead. Every polygon you step across, every rising bubble of nitrogen, is a direct result of the energy produced by the decay of atoms deep in that rocky center. You are walking on the literal expression of the planet's internal life, a visual representation of the energy that still hums within its core. Notice how the gravity affects your perception of the terrain. Because you weigh so little, the steepness of a slope is less about physical effort and more about visual perspective. You can ascend a 30-degree incline of nitrogen ice with the same effort it takes to walk on a flat sidewalk on Earth. This low gravity also means that the angle of repose, the steepest angle at which a pile of granules can remain stable, is different here. Methane dunes can have much steeper faces than sand dunes on Earth, creating sharp, dramatic ripples in the landscape that look like frozen waves. At this very moment, consider the concept of sublimation pits again. Scientists have found that these pits are often aligned with the direction of the sun's path across the sky. As the sun moves, it carves these pits into the ice, creating a landscape that acts as a giant sundial. The shapes of the pits reveal the history of Pluto's seasons over the last several centuries. Each indentation is a record of a specific moment of solar warmth, a physical memory of the sun's distant touch. The temperature here is so stable that weather, as we know it, is almost non-existent. There are no clouds of liquid water, no thunderstorms, no sudden shifts in pressure. The only changes are the slow seasonal migrations of gas from one pole to the other. This stability creates a sense of profound permanence. The nitrogen molecules you are stepping on today might have been in this exact same polygon for the last 10,000 years. There is no decay here, only transformation. Nothing is lost. It is simply moved, frozen, and moved again in an eternal, the silent cycle of deposition and sublimation. As you stand amidst the towering penitence of methane ice, let the silence of the Kuiper Belt settle into your mind. This is a world where the laws of physics are the same, but the materials are different. creating a reality that feels like a dream, but is grounded in rigorous frozen fact. The glaciers are not just ice. They are a living system, a slow-motion engine driven by the warmth of a rocky core and the distant light of a cold sun. Feel the gentle, buoyant resistance of the nitrogen beneath you, and let your journey continue deeper into the heart of the heart, toward the quiet edges where the ice meets the dark sky. As your gentle trek across the nitrogen plains begins to slow, notice how the distant sun, that cold and brilliant star, starts to dip toward the horizon. On Pluto, a single day, the time it takes for the planet to complete one full rotation on its axis, lasts about 153.3 hours, or roughly 6.4 Earth days. Because the rotation is so incredibly slow, the transitions of light and shadow happen with a gradual meditative patience. What's happening now is the start of a long, deep twilight. The shadows of the water ice mountains, the Hilary Montes, begin to stretch across the polygons of Sputnik Planitia, reaching miles over the ice. These shadows move with the same imperceptible speed as the glaciers themselves, a slow-motion curtain being drawn across the world. Consider the step-by-step process of how the atmosphere begins to change as the light fades. This is a phenomenon known as atmospheric collapse, a cycle that scientists have observed with great interest. As the surface temperature drops even by just a few degrees, the nitrogen gas in the thin air loses its kinetic energy. The molecules slow down, moving closer together until they can no longer remain in a gaseous state. They undergo a process called deposition, where they transition directly from gas to solid. Imagine a fine microscopic mist of nitrogen crystals beginning to settle out of the sky, falling at a rate of only a few centimeters per second. This isn't a storm. It is a silent, crystalline rain that coats the landscape in a fresh, white layer of nitrogen frost, one molecule at a time. Notice how the convection cells beneath your feet respond to this cooling. Deep within the 10-kilometer thick glacier, the cycle of heat continues its rhythmic work. Scientists discovered that the center of each polygon is a few degrees warmer than the edges. As the surface cools, the slightly warmer nitrogen ice at the center continues to rise at its steady pace of roughly 6 centimeters per year. Once it reaches the surface, it spreads out laterally, moving toward the dark troughs at the edges of the cell. When it reaches these boundaries, it has cooled enough to become denser, and it begins its long, slow descent back toward the base of the basin. This process is the very definition of a slow-motion world, where a single cycle of rising and falling can take 500,000 years to complete. As you stand still now, let your breath synchronize with the 248-year orbital rhythm of the planet. Scientists found that Pluto's orbit is highly eccentric, in meaning its distance from the Sun varies by nearly 2 billion miles over the course of its long year. We are currently moving toward the period of aphelion, the point where Pluto is furthest from the Sun. During this phase, the entire planet begins a century-long process of cooling. The atmospheric pressure, which we measured at 10 microbars, will gradually decrease as more and more of the nitrogen air freezes onto the surface. This is the planet's version of a long, deep hibernation. The glaciers you have walked upon will become even more stable, more silent, as the atmospheric energy fades and the world settles into a crystalline stasis. Consider the quiet behavior of the tholin particles in the upper atmosphere. Scientists discovered that these organic aerosols are formed about 200 kilometers above the surface. As the sun sets, the photochemical reactions that create them begin to slow. The existing particles, which have been suspended in the 20 distinct haze layers, begin their final descent. Because they are so small, only about 0.5 micrometers in diameter, they are incredibly buoyant. It takes nearly a month for a single tholin particle to fall from the top of the atmosphere to the ground. Picture this invisible reddish dust drifting through the blue haze, eventually settling on the dark highlands like a soft velvet blanket. This process of photochemical raining is how the ancient regions of Pluto, like Cthulhu Macula, have acquired their rich mahogany color over billions of years. Look up at Charon one last time. Because Pluto and Charon are tidally locked, this moon will never move from its position in your sky. Scientists call this mutual synchronous rotation. It means that for the next 153 hours of the Plutonian night, Charon will remain your constant unmoving companion. It reflects a tiny amount of sunlight back onto the glaciers, a phenomenon called Charon light. This light is about 5 times dimmer than moonlight on Earth, providing just enough illumination to see the shimmering edges of the nitrogen polygons. The gravity between these two worlds continues to create a subtle tidal pull, a rhythmic stretching of the interior that generates a few milliwatts of heat per square meter. Just enough to keep the hidden ocean liquid, just enough to keep the planet's heart beating. Now, as the observation comes to a halt, feel the stillness of the nitrogen ice absorbing any remaining movement. The processes of the world, the sublimation, in the convection, the deposition, are all moving toward a state of rest. Just as the nitrogen molecules slow down and settle into a crystal lattice, your own body is finding its place of perfect stability. The temperature of the world is 40 Kelvin, a place of absolute quiet, and you are bringing that quiet inward. The vast, slow cycles of the Kuiper Belt are not separate from you. They are a mirror of the rest you are now entering. What's happening now is the transition from the external world to the internal. The blue hazes of Pluto are fading into the darkness of the long night, just as the images of the glaciers are fading into the soft focus of your mind. The 3.7 billion miles between this world and the sun create a sanctuary of distance, a place where the noise of the solar system cannot reach. You are in a cold trap of peace, a basin of tranquility where every thought is being smoothed over by a layer of fresh, white frost. Notice the weight of your limbs, which feels slightly more present now as we depart the low gravity of the ice and return to the comforting embrace of your own bed. The buoyancy of the walk is replaced by the solid, secure feeling of rest. The nitrogen has settled. The methane dunes are still. The cryovolcanoes have finished their slow, viscous work. The entire planet is prepared for its 100-year sleep, and you are prepared for yours. Let these affirmations settle into your mind like tholins settling on the crimson peaks of the Montes. I am as still as the water ice mountains. My breath is the slow, steady rhythm of the nitrogen cycle. I am grounded in a peace that spans billions of miles. The darkness around me is warm, protective, and deep. Like the hidden ocean of Pluto, my inner world is calm and sustained. I release the activity of the day, allowing it to sublimate into the past. I am as stable as the bedrock of the outer solar system. My mind is clearing as the haze settles into the quiet night. I am safe in the vast, silent beauty of the universe. The gravity of sleep is gently pulling me down into rest. Every cell in my body is finding its perfect, frozen alignment. I am a part of the enduring, patient history of the stars. There is no rush, only the slow drift of the glaciers. The light has faded, and the stillness is complete. I am exactly where I need to be, in the heart of the quiet. The stars above are constant, and my rest is secure. I am sinking into the soft, yielding peace of the ice. My thoughts are as light as methane frost, drifting away. The world is at rest, and I am at rest with it. The 248-year journey is a cycle of peace, and I am in its embrace. The long twilight has ended. The nitrogen plains of Sputnik Planitia are bathed in the soft silver glow of Charon light. The molecules have found their places. The convection cells have completed their turn. The blue haze has settled. There is only the deep velvety dark of the Kuiper Belt, a silence so profound it covers everything like a soft, heavy quilt. You are drifting now into that same silence, into a sleep that is as vast and peaceful as the distance between the worlds. The journey is complete. The ice is still. Good night.